Okay, in general, a circle, you might, during your mathematical years, your years in mathematics, in learning mathematics, you might be taught about circles. Circles in general, a circle in general, it's defined as a set of all points in a plane at a given distance from a given point. The given distance is called the radius, and the given point is called the center. What do I mean by that? I'm going to show you as soon as possible. Let me click on this. That given distance is what we call the radius. And the given point is called the center. Here, this is at, not A. So here, as you can see, we have a point here in the middle called S, okay? And far from S is R, and then from R, if you keep that same R distance from S and you go round until you come back to R, you form a circle. That's why it's called the set of all points in a plane at given distance. That means from S to R, if you trace here again from S to the given point, one point, the one part of this shape is also another R, and it goes on like that. And inside of the circle is the interior part where a lot of things gonna happen, and we're gonna learn about as we move on in this topic. The outside too is the exterior part. We're also gonna learn a lot about as the things as the study goes on. And another thing is that circles are also named. So most of the time, a circle is named by the center. So this circle here is gonna be called circle S. So if I have a circle here and the center is P, this is gonna be called circle P because of the center, okay? The circle is always named by the center. And other things that we studied last week, Friday, on Desmos are things that will be here that we're gonna quickly talk about. A chord. A chord is a line segment whose endpoint lies on the circle. So as you can see here, I have D and E. This is a line segment and the endpoint lies on the circle, okay? D and C lies on the circle. So D and C becomes chord. So I'm gonna write, let me change color to something redder. DC is a chord, and it's always represented by, this straight bar on the two letters there. And can someone name another chord here? If you look at B,
FC.
okay, FC, F to C here too is a chord because from F to C. Another chord. In terms of chord, we're able to name this. Is there another chord you can see here?
BG.
Okay, the blue line here also is another chord B. From B, B and G are on the circle, so they form a chord, so BG. And in terms of a radius, we also seen radius last week, Friday, when we were drawing things on circles and the inside and using decimals. So a radius is a line segment that starts at the center and end on the circle. So it starts always at the center. end on the circle. So here, can someone give me one radius here? Start from the center. The center is E. So if you start from the center, you move on the circle. We have 3 of them here. We have 3 radii here. Can someone give them to me? Savannah, can you name one radius here? The radius, the definition said it's a line segment that starts on the circle and that start at the center and ends on the circle. You start from the center, then you go outside. So name one of the 3 radii we have here. You said DE, so D to E, because we have a line segment here. One, this is the center and then the circle here. So this is DE. Avalon, can you name one radii? One radius rather, I'm sorry. Avalon?
Yeah.
Can you name a radius here?
BE.
Okay. B starts on the circle and then E is at the middle. So this is another radius, BE. Aiden, can you name the last radius here?
GE.
Okay, GE. Good. So GE. And then this is another new word here. So here we are just trying to see vocabularies on that circle. So a diameter, it's a chord that goes through the center. A chord that goes through the center. So here, the only chord that goes through the center and has its 2 endpoints on the circle, because the definition of a chord is a line segment whose endpoints are on the circle, okay? But if a chord goes through the center, that chord becomes what? The diameter, okay? Like DC is a chord, and then since BG is also a chord, BG here is also a chord, but since it goes through the center, it becomes what? A diameter. That's why it said it's a chord that goes through the center. A chord has its endpoint on the circle. And then once a chord goes through the center, it becomes the diameter, okay? So here we have B, G as diameter. So B, the diameter is always twice the radius. And on Friday too, we learned about tangent line. And we said a tangent line is a line that intersects a circle at exactly 1 point. Let me change to which color? Green. Okay. A tangent line is a line that intersects a circle at exactly 1 point, called a point of tangent. So here you're gonna see tangent. On Friday, when I was drawing circle, I said when you put a point here and then you draw a line that passes through it, so this becomes the tangent line. So here, can someone name a tangent line here? We only have one here. Can someone name it?
BA.
Okay, BA. The blue line here is a tangent line. The blue line is a tangent line. So I'm gonna name it BA. And the symbol of tangent is different from chord and radius and diameter. To show the tangent line, you have to put a straight line and then put start and end arrow, okay? This shows the symbol of tangent line, okay? And what is the tangent point? The point of tangency. The point of tangency is a point at which, that line touches the circle. So can someone give me the point of tangency here? Jovara, what is the point of tangency here? At which point this line, this blue line cuts the circle, touches the circle? Yeah, does it touch the circle? No, look at this point. No, what does it touch? This blue line. This blue line, what does it touch the circle? At which point? A or B?
You said which way on the side?
Yeah. When does the blue line touches this circle?
Oh, I see.
At B. Okay. So that point B becomes a point of tangency, okay? So here, since it touches the circle at B here, so that B becomes a point of tangency, okay? And in a circle too, we have angles. So let's go through the sequence first. A secant, it's a line that goes through a circle. So here we're learning terminologies. So by next week, when we start deep, so when I talk about secant, when I talk about tangent line, radius, diameter, you should be able to figure out what I'm talking about. So a secant is a line that goes through a circle, okay? So as you can see here, the diameter has its endpoint on the circle. A chord has its endpoint on the circle. But a secant goes beyond the circle, okay? Even though it has 2 points on the circle, but it goes beyond. So which of these lines here is strictly, goes through the circle and then goes beyond it? Which one, Savannah? Which line goes through the circle and goes beyond it? Okay, FC, as you can see, F, even though F has one endpoint here, but it doesn't end there, it still goes beyond. C2 just touches the line here, the circle here, but it still goes beyond, okay? FC is a chord and at the same time a secant because it has its endpoint on the circle and also goes beyond the circle. So, okay, FC, here we said it's a chord and here it's also a secant. And FC has the same representation as tangent because we don't know the endpoint, okay? BA, we don't know the endpoint because B has, B is only on the line, but we don't know where this arrow goes to. It goes to infinity. Here to A is on the line, but we don't know where this arrow goes to. It goes to infinity. That's why we put that same symbol on top of BA. Same thing on top of FC because, once you go beyond F, this line just go downward, downward, downward until you exhaust the screen. Here too, you go upward, upward until you exhaust the screen. Okay, demo. Then another thing to learn today, it's about central angles. So a central angle is an angle whose vertex is the center of the circle. So here we're going to talk about angles. B, if you start from B, can I clean all these things I've done here? Here now we're going to talk about angles. If you move from B, angles are formed this way, and the vertex is always the letter in the middle, because to form an angle you need 3 letters. Like B, if you want to talk about BCE, the angle here, the vertex here is at E, the letter in the middle, okay? So since the definition of vertex says a central angle says it's an angle whose vertex is the center of the circle. So the center of the circle is E. So you're gonna see from E, you can move to B and to D to form a circle, to form an angle. So the angle from here gonna be what? A central angle. The central angle means the middle letter of that angle would definitely, need to sit on the center of the circle. So here, one of the central angles is going to be, and angles are read from the beginning, the vertex, and the end. And the 3 points out, the beginning and the end has to be on the circle, and the vertex has to be at the center. for a central angle, okay? So here we have BED. Angle is always represented by this less than from symbol, BED. And if you check again, we can as well move from D to E and then downward to this place. So this is another angle, DEG. So this is another central angle, DEG. And another central angle, which is even 90 degrees, is the whole of this, BEG. This is 180, okay? But you know, the angle formed on the diameter too is also a central angle, okay? But I'm not gonna just stress you with that. So we just take the two we know. And another remark here is that a central angle, the central angle sides are always the radii, which means if you take the side of this red angle I formed here, one side is the radius and the other side is also another radius. If you take the yellow angle that I formed here, DE is a radius and EG is also a radius. That's why the remark says a central angle sides are radii. So if you are forming central angle, make sure you always take the radii. Take two radii, join them together, you're gonna form a central angle. So if I want to form another central angle, if I just create a radius here, I just join to this. This is another central angle. I want to create another central angle, I just create another radius here and then join. This is another central angle. And it goes on like that. Then the next thing is to talk about inscribed angles. So an inscribed angle is an angle whose vertex is on the circle. So I'm going to show that to you. The inscribed angle this time around, you know, the central angle has its center, you know, as its vertex as the center of the circle. The inscribed one, the center is also on the circle. So if you take like this angle here, this is an inscribed angle, okay? So the sides are mostly the chords, okay? Whenever you take the side two, when you join two chords together, you form an inscribed angle. But when you join two radii together, you form a central angle, okay? So here DC is a chord, FC is also a chord, and then when you join them together, you have an inscribed angle. So DCF is an inscribed angle. So the notice is that an inscribed angle side are chords. So here today, the inscribed angle sides are chord and the central angle sides are radii. When you join two radii together, you form an inscribed a central angle. When you join two chords together, you form an inscribed angle. On the other side of the paper, gonna also be things we talked about on Friday. First of all, congruent angles, congruent circles are circles that are on the same size. When we talk about congruent triangles, so they have to have the same size and same angle. Okay, here too, congruent circles are circles that are of the same size. Their size can be measured by the radius. As I told you on Friday, you can compare angles, you can compare circles by the radii. Okay, the one with the small radius will be the small angle. The one with the big radius will be the big angle. Okay, sometimes if you don't know the radii, so you can also compare them by the diameter. Diameter is just the longest chord, okay? And it has to pass through the center of the circle, like twice the radii on a straight line. So the circle with the smallest diameter is the smallest circle. The one with the biggest diameter is the biggest circle. Or sometimes you can also compare them by their circumference. Let me type this one because my handwriting is quite ugly. And the circumference is just the distance around the circle. So when you are moving, if you are drawing a circle, that's the size of the circle. If you are drawing a circle, you move from here till here. That's the size of the circle. That's what we call the circumference. Okay. So here, if I have this circle with center A, so this is circle A, and then I have another circle here with center B. So if these two circles are congruent, that means they're going to have the same size. They're going to have the same either radii. If this is 2, this has to be 2. If in terms of diameter, if the diameter is 4, here the diameter has to be 4. And then I'm going to say to say that two angles are congruent, this is the symbol. Just draw small angle, small circle, and then put the center. Since this circle is named after the center, so this is going to be circle A, congruent to circle B. So if you do something like this, for a mathematician that, once you do this kind of representation, you put this small 0 and 1 dot inside, you put B, he knows that you're talking about circle B and circle A. And the symbol in the middle represents congruence, okay? Then concentric circles. I think we've done that on Friday, where concentric circles are when one circle is inside the other and they have the same center, okay? On Monday, we talked about it. So that the example was, I did something like this, and we had another circle inside, and this was the center A. The radius of this yellow line is the radius of the small circle A, and then this green line is the radius of this big circle A. Both circles are A, okay, because they have the same center, but different sizes, okay? So the concentric circles are circles with a common center. So here we're gonna say circle A, they are both circle A's with radius. So to this, we have two circles A here, but then to distinguish them, we have to distinguish, they have to be distinguished by their radii. So if there's a point B here, let me say point C here. So AB gonna be the radius of the baby small circle with radius AB. And the symbol of radius is always this small bar on top of the alphabet. And we're gonna call it small. That's the small circle. And then circle A with the radius of the second circle gonna be A to C, the green line segment. And that will be the big circle. Both are circle A's, but they are distinguished by their radii. The radius of the small one is AB, and the radius of the big one is AC. And on Friday too, we talked about internally tangent circles. And we said that internal tangent circles are circles that intersect at one point, and one is inside the other. So here If we have this small circle here, this one as the center, and then we decide to have another big circle around it, and this one has a center here. Since they touch at one point here, okay, so that means you can draw a tangent line here. So the point of tangency is this black dot here. So here we can say we have an internally tangent circle. One is inside the other, and then they touch at both, one circle is inside the other and they touch at exactly one point. Okay, the two circles touch at one point. So they are internally tangent. And then lastly, we also saw this externally tangent is when they're outside each other, but they touch at one point. So it means if I have a circle here with a center here, and I decide to have another circle that just touches this guy here, his own center here. Since they both touch here, I can draw a line of tangency. So here, this green dot here, it makes these two circles to be externally tangent circles, okay? So external tangent circles are circles that intersect at one point and they are side by side. As you can see, the two circles are side by side and they touch at one point. But the internal ones, one is inside the other and then they touch at one point. So take home today, we're able to name circle. We know that to name a circle, you have to talk about the center. So when they talk about circle B, if I say circle B, you should be able to know that it's something of this nature. A round ball with a center and then B at the side. And then also, if we talk about chord on a circle, is when you take 2 points on the circle and you join them together, okay, you have a chord. And also when we talk about radius in the circle, you should be able to know that when you have the center of the circle, any movement from that center to one part of the circle is what we call the radius. And if we talk about the diameter of a circle, you should be able to know that if you have a circle with a center here, once you draw a line that passes through that center, you have a diameter. And the diameter is twice the radius that we're gonna know later. And diameter is also the longest chord, because chords also says a line segment whose two endpoints are on the circle. Diameter also has its endpoint on the circle, okay? And we also talked about tangent line. The tangent line is a line that just passes through the circle and touches at exactly one point. And that point where the tangent line touches the circle is what we call point of tangency, okay? And we also talk about sequent. A sequent is just a line that goes through the circle and it goes beyond it. And we also talk about central angle and inscribed angle. Central angle is the angle that is formed with this vertex at the center of the circle. So if you are joining two radii, the angle that is formed is what we call central angle. And if you join two chords, the angle that is formed is what we call inscribed angle, okay? Because the vertex is always on the circle. And we also talked about congruent circles, that those are just circles that have the same size. And how do you know that two circles have the same size? Is by comparing either the radii, either the diameters or the circumference, okay? The radius again is the distance from the center to any point on the circle. Diameter is a straight line which endpoints on the circle and passes through the center. And the circumference is just the whole distance around the circle. And we talk about central circles. These are circles that, that are inside each other, sharing the same center. And we also talked about internally tangent circles. These are circles that are inside each other and they touch at exactly one point. So that means they don't have the same center. So the difference between the concentric and internally tangent is that The concentric, they have the same center and they do not touch. Whereas the internally tangent, they touch and they do not have the same center. As you can see here, the center of this guy is this red guy. Let me put the other circle in maybe black. The center of this one, the small one, is black, and the center of the big one is red. And the externally tangent, they don't have the same circle. They, they are side by side or outside each other, and they only touch at exactly one point. Okay. So these are the things we needed to learn today. Make sure you also go back and fix your. Oh, let me share my screen again. I'm sorry.